Understanding momentum and its conservation. Momentum is defined as a product of mass times velocity. It is a vector quantity and is in the direction of velocity. Conservation of momentum states that total momentum of a closed and isolated system always remains constant. Isolated system is the one where there is no external force applied, and closed system is the one where there is no exchange of mass. Real-world example involves collision. Collision is of two types. Elastic collision, where there is conservation of momentum and kinetic energy, and inelastic collision, where there is only conservation of momentum. Under elastic collision, the equation tells us that total momentum of two interacting bodies is the same before and after the collision, which means m1u1 plus m2u2 is equal to m1v1 plus m2v2. Under inelastic collision, the example involves two separate masses m1u1 plus m2u2 joined together to form a bigger mass m, which goes with a single velocity v. Explosion. Explosion is also an example of conservation of momentum. This involves a mass m, which is having two parts, a cannon and a ball. Initially, the cannon is at rest, so the initial momentum of the system is zero. In that case, before the explosion, if the momentum is zero, then after the explosion too, the momentum has to be zero, which means m1v1, the momentum of the ball, should be exactly equal to m2v2, which is momentum of the cannon. But since ball is moving forward, it has a positive momentum, and the recoil velocity of the cannon gives it a negative momentum. This also forms an example of action-reaction as per Newton's third law. Momentum in action involves collision, sports, and rocket. Momentum is a vital concept in physics, and its conservation is a fundamental principle that underpins various real-life phenomena.